Hi class, welcome back. I'm Dr. April Ström, and we have yet another video of U-Substitution for you that again here is going to be an example where we are off by a constant. Okay, so let's try to tackle this one. Again, like previously, we need to identify what the integram looks like. Okay, we see we have two functions here, an x cubed being multiplied by a square root of x to the fourth minus 1. And then we need to identify what the inside function is, because if we can identify that, then maybe that's our u. So I look closely and I see, well gosh, I have a radicand of x to the fourth minus 1 hanging out here underneath this square root. That's most likely my inside function. So let's let the u be that inside function there. So we have that u will be equal to x to the fourth minus 1. And like before, we'll go ahead and find that derivative of that equation. So du is equal to, well, this is just power stuff. So we have 4 times x cubed. And then I was taking the derivative with respect to x, so multiplied by dx. That's here. Okay, wonderful. So I at least have an exchange for what du is. It's 4x cubed dx. I reflect back on my problem and I notice, well, gosh, I have an x cubed. Fantastic, I have an x cubed here. I have a dx. Fantastic, I have 1 here also. But what I don't have is this constant of 4. What I need is off. What I need here is off by this constant of 4. So just like in the last problem, what we will do is get rid of that 4, at least on the right side, and put it on the left side. So we'll divide both sides by our 4. And in doing so, on the left side, let's write this as 1/4 du is now equal to just x cubed dx. Now I have a straight up exchange here for my x cubed dx that will be put in the place of the x cubed dx over here. And what will appear in its place though is 1/4 du. All right, so now I have my original problem is going to be equal to the integral of, well, the pink box is here, x cubed dx. Let's go ahead and write that as the 1/4 du, and we'll do that here at the end, 1/4 du. Again, I like to put my du's or d whatevers at the end. We'll deal with that constant in a minute. And then I still have a square root of this stuff, but this stuff here, x to the fourth minus 1, that's just our u. So I can rewrite this as the square root of u. So far I have now the integral of the square root of u times 1/4 du. Okay, great. Well, like we saw in the last problem, I've got a constant. In this case, it's 1/4. We can put that in front of my integrand, and then we can actually take it all the way out of my integral because it's a constant. We're allowed to do that by virtue of properties of integration. So let's just go ahead and move that on out in front of the integral since we know that's going to happen. And then I notice here, I'd like to really write the next piece, the integrand here, but you know, when we have square roots and we're trying to integrate things that have roots, it's always best to go ahead and rewrite it as a fractional power. So let's do that here in this step. So I'm just rewriting, I'm not integrating yet. So the square root of u is simply just u to the 1/2. That's just a rewrite. Those are equivalent. I moved the 1/4 out already and now just drop down the du. So I have done my u substitution so that now here's what I actually have to integrate. I have 1/4 times the integral of u to the 1/2 du. So now you have to think, okay, well, how do I find the antiderivative of u to the 1/2? Well, the answer to that is reverse the power rule process. The power rule, initially, if you're finding the derivative, you would have to bring the power down in front, subtract 1 from the power. But if you reverse that, what we then do instead is add 1 to the power, divide by new power. Okay, so if we do that, we still have our 1/4 here out front. And now we're going to multiply. Now I'm actually taking the integral here, so no need to write the integral symbol at this point. We're going to multiply by my antiderivative of this. So if I add 1 to the power, so I have 1/2, I'm going to add 1 to the power, but now I'm going to divide, let me extend this here. We're going to divide by new power. Well, that was the 1/2 plus the 1 that I added to my power. Okay. And then of course I have to add my plus C. I always like to do that so we don't forget, right? It's notorious that we often forget the plus C. So I put it right here. Now let's just clean this up if we can. I know what 1/2 plus 1 is. That's just 3/2. And that's the same as the denominator now. So we have 1/4 times u to the 3/2 power, but divided by 3/2 plus c. Okay, again, though I'm not done because I can't leave my answer with u still in it when I didn't start with u's, right? We started with x's. So we have to go back and exchange out all our u's, which luckily we only have one, and that will be an exchange of x to the 4th minus 1. And if you really wanted to simplify the 1/4 and the 3/2 down here, you could do that too. I'm not, but I will leave that part to you if you like. So I'll just leave my answer as 1/4 times, instead of a u, I'll have x to the 4th minus 1. That whole thing though is taken to the 3/2 power and is being divided by 3/2. And of course we add c at the end. And so there is our final answer for this particular U-substitution problem. So I hope you enjoyed that video. We have more videos coming up that are a little more difficult and challenging problems involving U-substitution. Don't forget to click on the EdVantage logo to subscribe to our channel. Thanks.